Popular programming languages, like Java and JavaScript, have had the switch statement for a very long time. This feature makes it easy to do simple comparisons in a readable way. Python, being a very popular and major language, lacked this feature. Until now. Python 3.10 introduced the match statement, which is similar to a switch statement, but more powerful using a programming pattern called structural pattern matching. Let's try it for ourselves. If you have not subscribed yet, please click on the subscribe button below and enable notifications to get notified when new videos are released. First, we must download Python 3.10. Since the match statement is only available in this version, as at the time of this recording, Python 3.10 is in beta. So to download, we must check the pre-releases page and download the one for your operating system and install it. After installing, we can now test out this cool feature. I'm using Visual Studio Code for this demo, because it makes it quite easy to switch between different Python interpreters. Let's look at a simple use case where we match to a literal like an integer. The syntax is similar to a switch statement in other languages. But, instead of using the word switch, we use the word match instead, followed by the cases. In this example, we want to execute a print statement if we match a 404. Let's run the script. To run with Python 3.10, we must change the Python interpreter in VS Code like this. Then right-click, then click on Run Python File in Terminal. After running, we see the output in the terminal. We can even combine several literals in a single pattern, using the pipe symbol. Here, we want to match either a 403 or a 404. We can also use the underscore to make a default case. When no match is found, that case will be executed. Let's run the script. A match was found. This is because we passed 404 to the function. We can also use list and tuples in a match statement. We can then bind a variable to any value in the sequence. In the pattern passed to a case, we can represent a particular value by an arbitrary name. Let's run and test this out also. The first case was matched. The value 20 was binded to the variable y. Let's match the second case by changing the first value to 100. Here, the value 100 is binded to the variable x, and the value 20 is binded to the variable y. Let's see another example involving a list. In this example, we are trying to match an empty list, a list with a single element, a list with two elements, and another with more than two elements. Notice that sequence patterns support wildcards, like those used in unpacking lists and tuples. This is denoted by the asterisks in the fourth case pattern and allows us to bind the remaining items to a variable. In the output, we see our matches. This is not limited to lists and tuples alone. It even works with dictionaries. In this piece of code, we are trying to match two patterns. The first pattern matches a dictionary with these two keys, first name and last name. The second pattern matches a dictionary that contains a key and a value of language and Python respectively. We can use double asterisk to denote that it should match any other key-value pairs. Observing the output, we see that it gave the desired result. The remainder of the second dictionary was binded to the variable, other info. We can also match classes and objects. Let's create two classes, rectangle and square. The rectangle class takes two instance attributes, length and width. The circle class also takes one attribute, radius. Let's see how we can match these objects from these classes. In the cases, we use the class name. Then we show how that particular object should look like using keyword arguments. In this example, we want to match a circle object and bind its radius value to a variable. Likewise the rectangle object. Let's call this function and run the script. As I said earlier, in the patterns passed to the match statement, we must use keyword arguments. But what if we want to use positional arguments instead? Let's try that out. We get an error that says that the circle object accepts 0 positional arguments. To fix this, Python 3.10 has introduced a special class attribute, match args. This must be assigned to a tuple containing strings. It tells the order for the class attributes passed to the pattern. The string elements must correspond to the attributes of the class. In this case, that attribute is radius. Let's run our file again. We no longer get that error. Another thing to note is that the match statement takes into account the inheritance hierarchy. So if we try to match a child class against its parent, it will produce a correct match. Let's see what I mean by this. Let's create 2 data classes, A and B. Class A is a parent of class B. In this example, we want to match an object created from class A. In our test though, we pass an object from class B. What do you think would be the output? Let's run the script and see what happens. Interestingly, we get a match. This is because class B is a child of class A. So take note of this to avoid any logical errors. One final feature I would like to touch on is that we can use guards or conditions in a match statement. In this example, to produce a correct match, X must be greater than Y. Let's run the script. We got a match. I hope you enjoyed this walkthrough. If you liked it, please subscribe, like, and share.